Hello everyone, I'm Marius Högger. I'm an AI and software engineer here at BBV Software Services in Zurich. And today I want to talk about AI agent orchestration. I want to show how and what is needed for AI agents to be able to communicate. I only have 5 minutes, so let's get started. So for the past 2 years, a colleague of mine and me, we've been building on a multi-agent system, solving various use cases with groups of AI agents. Because we quickly realized that the collection of AI agents is much more powerful than just one generalistic agent. Almost every task benefits from being split down into subtasks. Same applies to AI agents. An agent with one specific knowledge is easier to manage, less likely to drift away from its intended context, and therefore is also much more reliable. However, enabling agents to communicate with each other is not that easy. Initially, I thought they can just communicate over natural language or text because that's their common interface. But to orchestrate agents, there's much more that's needed. For example, an agent needs to know about the capabilities of the other agents. To illustrate how this can be managed efficiently, let's take a look on the Model Context Protocol proposed by Anthropic. This protocol uses servers and clients. Servers provide information like data, for example, weather data or company policies or news, and they can also execute action. Clients, typically large language models or LLM-powered applications, perform tasks requiring these data from the servers. So servers expose so-called tools, described by their functionalities, the required inputs, and the expected outputs. The client then can evaluate, based on the tool's description, which tool fits best for the achievement of their goal, and then can provide the required inputs. You might wonder, what has this to do with AI agents? Well, an agent can serve both roles. It can be server, but also client. For instance, an agent being tasked to answer a question about weather can dynamically call a tool from another agent who's exposing its weather tool, and therefore the other agent is then the server. Through this approach of exposing tool definitions, agents become accessible to one another. However, not all agent tasks are as simple to just be resolved by one single request. Often tasks are much more complex and need multiple agent tasks and specific conditions to be completed. Such task needs internal states to track the progress. For example, also OpenAI, in their most recent release, the Responses API, they also introduced a stateful API. This is how important the tracking of the progress is. So agent must understand the current cause context and the previous achievements by other agents. To handle this, we took inspiration from the LangChain's agent protocol, which organizes the interactions into tasks, into runs and threads. Runs represent task executions, and threads groups related tasks together. For example, a thread could be the booking of a holiday, and a run could be the booking of just a flight. Now, it also can happen that the agent needs more information for the completion of their task. For example, it needs to know whether additional baggage should be booked as well. In this case, it can make a human-in-the-loop request, and then the initial flight booking request and the human-in-the-loop request to ask whether additional baggage should be booked as well. All these belong then to the same run because the task is not completed yet. This is where we actually use Azure Cosmos database greatly. We use it to persist our internal states, so the run and thread context. And here we use the flexible schema, the real-time data consistency, and the global distribution. This ensures that our run and thread context are always instantly available for all the agents. And by the way, we also store our agent or tool definition in the Azure Cosmos database. But most important for us is to quickly adapting to new AI developments and easily experimenting with new approaches. And here we also use Azure Cosmos database because its flexible schema and the ease of use allows us this to be greatly flexible and try out new things. And now let me briefly broaden out the perspective. Currently, most companies using or building multi-agent systems only focus on their own agent. But I truly believe agents are much more powerful if they collaborate together with, but especially also across company boundaries. Since first mentioning a global ecosystem for agents over a year ago, this has been inspiring me all the way. I envision agents to be rented out to other companies and integrate in their system, negotiating about contracts and building together on joint projects. This is why I've closely followed AI agent protocols, continuously adapting our system with the help of Azure Cosmos Database, preparing us to be ready when one of these protocols becomes state of the art. And with the recent announcements of OpenAI to support the Model Context Protocol, I believe this is the number one contestant. With that, I want to close. I provided here some more resources about different agent protocol approaches. And with that, I wish you all the best for the rest of the conference. Enjoy.